Controlling smart RGB LEDs is a little more complicated than controlling a conventional LED like the one you see here. To get started, create a new circuit in Tinkercad and change the name to Smart RGB LEDs. We can actually light up a conventional LED by connecting it directly to a battery as long as we have either the right voltage or a resistor that limits the current appropriately. However, to control a smart RGB LED, we need a microchip that can send it a signal. So we're going to use an ATtiny 85. If you don't see that option pop up, you may have to switch the menu option to all and then type in ATtiny again. To power our ATtiny 85, we're going to need a battery. And I'm going to choose the 1.5 volt battery option and switch it to 3 cells. And I'm also going to rotate it so that it lines up with my microchip. And then I'm going to attach the positive to the power pin on the ATtiny 85 and the negative to the ground pin. I'm going to rotate this microchip so that the wires don't cross. I don't have to, but it just makes it look a little cleaner and a little easier to see what's going on. I'm also going to put a few breakpoints in my wire just to make it extremely clear how things are connected. Last but not least, I'm going to change the color to match the convention of red being positive and black being negative or ground. As a reminder, I'm going to connect this conventional LED to this ATtiny 85 where we connect the cathode to ground and the anode to one of the pins that will send it information or send it power to light up. When you're using an ATtiny 85, you actually have to have a resistor in line, otherwise it'll destroy your LED. I found that out the hard way. This is a typical way to connect a conventional LED. A smart RGB LED connects differently. To pull up a smart RGB LED, type in Neopixel. A Neopixel is a version of a smart RGB LED that was created by the company Adafruit. The white thing on here is actually the smart RGB LED, and it's a special type of LED that's programmable. The actual names are called WS2812 or SK6812. The blue part surrounding this white rectangle here is the part Adafruit created. It's called a Breakout Board. They create these to make it easy for hobbyists to use these types of electronics. To use this one, we need to connect the ground to any black wire here, anything that's connected directly to ground. I'm going to connect it to this one. And then I need to connect the power again to anything connected to red here. And I'm going to connect it over here just so that my wires don't have to cross. It doesn't get too many wires in this area. I'll create a breakpoint just to make things look a little prettier. And again, I'm going to color my wires to help me keep track of what they're doing. The last thing I need is to connect the in to one of the pins on the ATtiny 85 here. These pins don't power the Neopixel, but they do provide it the information it needs to figure out which color it's going to show. I'm going to put another breakpoint in here just to show exactly how this wire is connected. And I want to take a minute to show the difference between a smart RGB LED and a conventional LED. The conventional one has 2 wires that connect it to the ATtiny, the power comes from one of the pins that we program. The Smart RGB LED, or the Neopixel here, it gets its power directly from the battery. The power does not have to go through the ATtiny85 to get to the Neopixel. The information about which color to show comes from a separate third wire. Now that we have our RGB LED wired, I'm going to go ahead and delete this conventional LED and its resistor because we're not going to use them. Now it's time to start coding. Click on Code, and we're going to switch from blocks mode to text. This is giving us a warning and letting us know that if we switch between blocks and text, we're going to lose progress. So when you make this switch, you must remember not to switch back. Otherwise, you're going to lose the code that we write now. This code here is used for controlling a conventional LED. We don't need it, so I'm just going to delete the 4 lines that are inside the loop and the 1 line inside the setup. To control a Smart RGB LED, we need to use a library. So I'm going to click on the Libraries button and go down to Neopixel and click on Include. You'll see a new line at the very top of your program that includes a library written by the people at Adafruit. This library does most of the work of controlling these Neopixels. It makes it very easy for hobbyists to use just a few commands to do exactly what we want to do. We still have to learn how to use this library though, so I'm going to click on Libraries again, and this time on the right hand side I'm going to click on the Link to Documentation button. We get a little warning letting us know that we're leaving the Tinkercad website and visiting an external site. That's okay because it's taking us to Adafruit's website, which is a reputable organization. As I scroll down, looking through how to use the Neopixel library Adafruit has created, I see the very first thing we're supposed to do is include that library, which of course we have already done right here. Next, we need to define which pin is going to control our LEDs. So I'm going to copy this line of code using Control-C or Command-C on a Mac and paste it above the setup but below the line that includes the library. And I have to change this number from a 6 to a 0 because the green wire here that carries the information is connected to PB0, which is pin 0. The next line of code I need to copy is the LED count. This tells the microchip how many LEDs are connected to it. In this case, we only have one LED connected, so I'm going to change this to a 1. Finally, we need to copy this line, which creates an object called strip. And I'm going to paste it right here. Again, all 3 of these lines are above the setup and below the line that includes the library. You'll see that this line that creates the strip object uses the LED count that we previously created and the LED pin which we previously created. I could just put a 0 here and a 1 here, but programming it in this way makes our code more readable and easier to maintain. The last piece here defines which kind of LEDs we have. As I scroll down, I see the first command we need to put inside the setup. It's actually the first and only command we need to put inside the setup. And if you look closely, you'll see that this first part here says strip. It says strip because when we created our object, we named it strip. You could just as easily call this pixels. If I did that, I'd have to change this to pixels. But I'm going to change it back to make it easy for us to follow the rest of the documentation here. As I scroll down, I see two commands that show me how to control the color of the Neopixels. The first one assumes we're using a red, green, blue Neopixel. The second one assumes we're using a red, green, blue, white. In our case, we're using just a regular red, green, blue Neopixel. Now, this is the documentation that shows us how to use it. If we scroll on down even further, we can see an example of how to use it. So I'm going to copy the example. You can copy either one, but you do need to make sure that you make a few changes. The first change we need to make is the first argument, which defines which Neopixel we're going to change. Because we only have one Neopixel, we're going to be changing the first one. And because arrays are zero indexed, and this information about how many Neopixels we have is stored in an array, we need to refer to it as the 0th item in the array. So we'll put a 0. The second number defines how much red we want to show. 255 is the maximum brightness of the 3 different colors inside this little white chip. There's actually 3 different LEDs. So we can have a maximum of 255 red, 255 green, and 255 blue. I just want to have red, so I'm going to delete the 255 for blue and change it to a 0. Now that I've defined what color I want to show for the pixels that I have, I need to go to the very last command, which is strip.show. The strip.show command tells the microchip to go ahead and light up the pixels as we've defined here. If I click Start Simulation, I should see my Neopixel light up red. Congratulations if you've made it this far. If not, look through your code and see how it differs from mine. Once you've got your Neopixel to show red, take a little bit of time to explore how to change colors. You can go ahead and change this to a 255 and we'll see a different color show. This is what we get when we mix red and green. Try playing with all of these colors. And remember, you don't always have to use 255. If you would like to use less red, you could put in 120 or 50.